Welcome to the security session by Jason Maynard.
Awesome, thanks. Can you guys can hear me okay? Thumbs up.
Yeah,
Okay,
you're coming
perfect. Just
through.
let me know if there's any latency. I'm on Starlink. It's been phenomenal. I'm out actually in the Rockies in Alberta, and I got fairly decent internet thanks to Elon Musk and Starlink. Um, So this session is going to be certainly interesting. I've taken kind of a capabilities-driven approach to the conversation. So what that means is that I try to abstract product and really talked about some of the things you want to think about. Now, it could be a plus or a minus, whether or not you think a control or capability is needed. But really, what it's meant to do is give you a little bit of perspective of some of the things that you could think about while going through an analysis of what you might need within a industrial environment, whether that be mining, oil and gas, doesn't really matter. At the end of the day, security is certainly a required element. And so the first thing that we'll talk about a little bit is mining, but this is interesting attack that took place with the Colonial pipeline. It was very disruptive. And what's interesting in this is that they made a decision at one point because it starts in the business network, and you're going to see a lot of the threats that happen typically do start in a traditional IT-based system, whether that be a business network, whether that be a Windows asset that's in an operational environment. Doesn't really matter. They're going to start with an IT-based system, and then they're going to proliferate from there. So what makes this one really interesting is not only did they pay the $4.4 million when they discovered the hack, they took a decision to shut down the pipeline. And we know the impact of this, right? It led to gasoline hoarding and soaring gas prices. In fact, I saw news clips where people had bags of gas, like bags of gas. They were filling up their bags because it took out, I think, the whole eastern side in regards to fuel. And they made this decision not because the operational environment was impacted, was they took the decision because they feared that it could impact the operational environment. And so the big thing in all of this is it all started with 100 gigabytes of data in a double extortion scheme. Obviously, they were holding that data as hostage, and they threatened to leak it. After discovering some malicious software in the business network, as I mentioned, they shut down the pipeline to prevent it from spreading. So, visibility of your threats might exist and how to contain them is critically important, especially for an operational environment. But it's very challenging for the adversary to get into an operational environment and understand the nuances that happen within the operational environment, like the processes, what does what, the safety control systems, all of that stuff takes somebody with a level of skill. And it's not that they're going to jump in and cause disruption very easily, and that's going to take some time. But because they didn't know where things were on the business side, they thought the operational side was at significant risk. And things may have changed from the original read that I've done from this, but and again, they proactively shut down that pipeline. We certainly don't want to get into a position where this happens. And so, the business and the operational networks, it's not going away. I know a lot of times I hear people say, well, they were islands before, we didn't have these profiles or risk levels, and things worked back then. The problem is people want data. Data is the new oil, or the new. That's where the money is in the data. And so if you can get operational efficiencies based on data, you're going to probably want to do that. If you could give real-time statistics back to your buyers, they're going to want it. Just think about it. Even from a home user, you order something online now. You order it online and you watch the little car come to your home. You want to know, what street are they on? How close are they to my home? Okay, and you're almost at the front door ready to greet them. Same thing with deliveries with Amazon or any exactly where it is. You want to know on the rail car where something is. And that's the type of data that these businesses are trying to give to their consumers, is real-time analytics of what's going on. And so With that, there's a ton of challenges. And so again, I want you guys to think about the complexity here. IT has tremendous value in the operational environment. And the operational teams have tremendous value in getting IT or traditional IT folks understanding the sensitivity and the concerns around operational processes in the environment as a whole. IT has been patching and taking and maintaining and securing systems for many years. OT is now being pushed. Haven't been developed with security in mind. There's a lot of legacy. A lot of times you put in gear into a location and then it's going to operate for 10, 15 years. And you don't want to refresh it. Now, again, that brings some risk. But the biggest risk is really the complexity and fragmentation of the environment. That's where the real risk is. And you tend to give the adversary, whatever that might be, right? A motivated attacker for political gain. It could be it doesn't really matter. Whoever's motivated enough to get into the environment is going to take advantage of this complexity, right? And so we're going to walk through this based on a system. It's going to get a little technical, right? We're going to talk about some of the controls or capabilities from the endpoint all the way to something that we're going to connect to. And that's the goal of this type of exercise is yes, there's product, right? Cisco has stuff that you're going to use and leverage to achieve your goals. But what you truly want to do is understand what is required in order to secure that environment. And so when you look at this, you've got an endpoint, right, that does stuff. And there's a tremendous amount of telemetry and insight that comes from this. So there's IP addressing, there's domains, there's URLs, there's hashes of files, right? There's emails, there's network flow data, there's vulnerabilities. You've got external tooling that the adversary may use. They may also live off the land. And what that really means is that they're going to use the processes that are available on the asset that they've compromised to, invoke their will within the organization. And then you've got what we call our tactics, techniques, and procedures. And as you start going up the stack, or in my case, down, it gets harder and harder for the adversary to overcome if you have defensive capabilities in play. So what that means is that if you're defending based on an IP address, I can change my IP address and bypass that control you have. It's that simple, right? If you're looking for a specific file with a certain hash and I change or modify that file, I've just bypassed your control. But if my technique and tactic requires access to PowerShell to invoke a behavior on the endpoint and you remove PowerShell from that asset, that's significantly difficult to overcome, right? That might mean that I've got to reprogram my attack vectors, whatever that might be, to now look for something else to leverage. And so that's what we mean by TTPs. At the end of the day, what we want to prevent is the adversary getting on our assets, whatever that might be. So as we look at this, we're actually going to take that step back. And the way you want to do this is you truly want to understand the flows. So if you have a remote support engineer, maybe he's going to use VPN to get into a location. Once they're in a VPN and connected, that's one flow. Then you might have an engineer on a jump box. The jump box has access to a specific system, right? And we're going to walk through 3 scenarios just to give you guys an idea of some of the things that you want to consider when securing that operational environment. Now, they don't always have to reside on the endpoint or on the network, right? But just take this with a grain of salt. These controls can be in other areas within the infrastructure, but they have to be there, right? They're table stakes now. So the first one, if you look at this, I've broken this up into 2 categories. You've got prevention, which is going to be blue, and then you've got detect and respond. And you can't do one without the other, really. And so prevention is going to say, something bad's happening, stop it. And we want 100% prevention, 100% of the time. The reality is there's not a single vendor on this planet that could give you that. And so that's where detect and response comes in, right? The ability to detect something if it does get in, and then having the ability to respond to that to mitigate my risk. So patching falls under patch 100% of my vulnerabilities 100% of my time, I'm certainly going to be better off than having systems with vulnerabilities within the organization. And what's interesting, if you look at a lot of the attacks, it only takes one system for them to get on. Once they get on, they actually leverage other techniques to move laterally within the organization. So that might mean that I compromise an endpoint and then use the access that I've gained by compromising that vulnerability to now move within the environment to find additional assets that maybe have a similar vulnerability or something new, or maybe I've harvested credentials and just logged in to other systems. So patching, system hygiene obviously is a big deal, and this is a big challenge in the operational environment. Now, it's easier for a field engineer's asset, because maybe that's a little bit easier to patch. But it's some of the other systems that might exist within the operational environment that need to be up 100% of the time and very difficult to patch. You get things like exploit prevention and system process protection. So what does that really mean? So exploit prevention just means that if an adversary is trying to execute arbitrary code within the system they've got access to elevate privilege, as an example, they're looking for a specific state within memory to execute that code. A little bit. That's what they're doing. They're trying to see that's going to allow them to expose that. And so one way of minimizing that risk is, in fact, randomizing that. So you keep the original code there, that becomes a honeypot, and then you scramble memory for the real process that's running. So when they go to look in memory for that, they can't find it. But we've captured it because we've got another copy of that original. And so that's certainly going to help mitigate risk. You get AV, so antivirus, anti-malware. You look at things like malicious activity protection. So these might not be some of the things you're thinking about on the endpoint in the operational environment. And so you might say, well, I need endpoint protection, and you go to market for endpoint protection. But these capabilities within endpoint protection becomes very, very valuable. And so something like malicious activity protection is going to prevent something such as ransomware gets on the box. It's bypassed every control you have in place, and now is starting to encrypt the drive, right? Starting to encrypt all the files. Well, that activity could suggest, well, that's not normal. And if you have some process monitoring that's not normal, I have the opportunity to stop that from happening, right? And prevent it. Now, you might have one or two encrypted files, but you don't have a whole drive of encrypted files. You've stopped that process from continuing. Then you get into things like application blocking. So maybe applications you do not want to have any network connectivity from the asset. You've got network blocking, so L3, L4, so IP address type blocking. You've got USB blocking, so maybe certain assets you don't want people to put in a USB key into the device. And you might say, well, why is that even important? Well, there's been known for folks to drop off fairly large USB keys at gates to facilities. And so they drop them off at the gate, and somebody comes walking in, sees it on the ground, and says, woohoo, I just found a 20 gig USB key. Fantastic. They go in, they plug in their laptop, they plug in that USB key. There's a weaponized PDF on it that launches, and the game begins, right? The adversaries bypassed every single that you might have just by leaving that USB key at the gate and hope somebody will pick it up. And so maybe one of the controls would be USB blocking. You've got intrusion prevention. That could be on the endpoint or further upstream. You've got firewalling. You've got fileless malware. So malware that runs in memory. There is nothing on disk for detection to take place. And so advanced capabilities to see fileless malware. So malware that runs in memory and detect that. And then finally, some marketing terms around AI or ML. But basically, you need some additional intelligence. You need to be able to know what good looks like. You need to know what bad looks like. And when there's an unknown, you're going to have the ability to be able to determine what part do they fall under. Is it really clean or is it really malicious? And one of the outcomes could still be unknown, but you need additional machine learning capabilities. So algorithms that are going to help filter out and get rid of some of that noise and detect it.
Hey, Jason.
Yeah.
This seems like a relatively, common approach for IT. Are you seeing that is necessary in the most protected OT environments as well? Like this is a lot of stuff, especially for the older OT machines. Like, what do you do with that?
Yeah, and that's where we're going to go, right? There,
Okay,
so
perfect. Sorry,
yeah.
I'm getting ahead
So
of you.
Roland, you about an actual traditional IT-based system, right? And so it's a
Right,
little bit
yeah.
easier to put some software on there to help minimize risk. But that's not the only area that you're going to be able to do that, right? Not everything can get an agent installed on it, or you could even have assets that even if you could get an agent, it voids warranty, right? The vendor that provides that technology is going to say, you know what? We don't support that, right? It hasn't been tested and validated, and you're putting the operations at risk, and we're not, supporting it. So you're going to have to
Okay.
look to the network. So I'm covering the endpoint, but remember, plug and play this. This could be any device. As I'm going through, there's other opportunities to add additional visibility and control.
Perfect.
Does that make sense, Roland?
Yeah, that's perfect.
So now we've got some of the prevention capabilities. Now this is going to be the longest part of the session, is building out this initial flow. And then the rest of the other two flows, we don't go in much detail because there is a lot of copy and paste. You're going to do a lot of the same things. Now on the endpoint itself, you've got a detect and response capability. Now, again, as Roland mentioned, not everything's going to have an agent. And so you may have to have these controls or capabilities somewhere else in the network. Especially as if you're using something like Purdue, as you get certain lower and lower in those levels, right? L2, L1, like you're going to be even more restricted on what you can and can't do. And so endpoint detection response is going to make sure that I understand what's happening. So for example, I plug in a USB key because I'm allowed. I open up a Word document, a macro launches, PowerShell connects to something nefarious because I'm in maybe between the business network and the operational network. So I'm a little bit inside, but I'm not fully deep, and I still have some connectivity outbound. How do you know that happened? If your defensive capabilities didn't see that, how do you ever know that is? How do you know the Word document had a macro that launched a PowerShell that made a network connection out to the internet to talk to something bad to pull down a file? Now, you could have other technologies upstream that might help detect that. Fine. Or if it's an endpoint that you could install an agent, I could detect that information here. Now, I will talk about other components to this around, and then maybe more of a detection focus only. So auditing as an example. Maybe on an endpoint, you don't want to do any prevention capabilities, but you need all the auditing capabilities, and we'll cover that as we move along. Forensic snapshot. So something on the endpoint you might not be thinking about, right? So if something happens in the environment, I would like to be able to take a forensic snapshot of the asset for my security analysts and responders to be able to review that to understand. You got host isolation. Again, you're going to take this with a grain of an operational environment, but you may want that ability, maybe on some assets, right? If something nefarious is taking place and you're making a decision of whether or not to shut down, as an example, a pipeline, or isolate or contain a threat within a segment in my environment, or maybe a host, I want maybe to have that ability. You get cloud-based IOC, so again, enriching the intelligence that you're picking up. And again, you might be saying, well, cloud and these field locations, that's not a thing. But we're starting to see it, right? You're starting to see some cloud-based HMIs, cloud-based technologies. It's like the phone system when it came to IT networks. People said, no way, it's never going to happen. Or, even business networks moving to the cloud. No way, it's never going to happen. It's only a matter of time. These technologies mature and provide significant business value before the organizations start to leverage it. Command line capture, right? Understanding that it was PowerShell that was launched, but I want to know that it was, say, something like made a connection using a tool called PowerCat to connect to something bad. I want to know that full command line argument that was passed. Then you get into sandboxing, so taking a file that's unknown, as I mentioned earlier, because you're not going to get 100% disposition every single time, so you're not going to know if it's unknown or malware. And so you're going to need to detonate that in a sandbox environment and analyze the outcomes. What behaviors are happening with that file that may suggest that it is nefarious? Vulnerable software. And this ties in with patching, right? If you're patching everything, but not understanding the vulnerabilities that may exist anywhere in the operational environment, you're certainly at risk, right? And so either patch those systems or put defensive capabilities upstream to ensure that you block them. Then you get into flow data or flow analytics from the endpoint. So I want to know that every connection on that asset, making any network-based connection, is tracked. And not only is it tracked, tell me who actually launched it. Was it Roland, user that launched the browser? Or was it Roland's asset, it was under NT Authority subsystem, that launched PowerShell? Very different, right? You're going to look at those very, very differently, especially in incident response. Now, I know that's a little bit deep on the endpoint, but these are some of the things that you want to think about when you're securing that operational environment. It's not a matter of just getting an endpoint product and installing it. It's got to drive towards a lot of these capabilities. If not, you have gaps. And does it mean that you're at risk? Well, maybe. But if you have that control upstream, maybe not. I've always said this, and I know Roland knows this, is if you defend at the asset that you're protecting, you have to be 100% correct 100% of the time. So this is not where I want to defend. That endpoint is not where I want to defend. I have to. I have to only because I know my other defensive capabilities cannot be 100% correct 100% of the time. I have to do it here. But that's not where I want to do it, because if I fail here, I'm compromised. All right, so now we're moving towards the network. Again, some of these controls could be in the network. I'm just giving you guys perspective. Start moving into the network side. There's things like DNS layer security. You got web proxy, DLP, data loss prevention, TLS decrypt, and advanced malware inspection, right? Or antivirus. And those are some of the preventative capabilities that one would desire to achieve there as well. Now, you might say, well, wait a minute, you said AV here, right? Why is it here? Well, remember, I have to protect here if this fails, but I have an opportunity to protect here. And if I can't, why not block it here in the network out there versus, further down? And I want DNS forensic data. I want full URI capture. And URI is the full URL that you type. You want sandboxing and file analysis. Now, you might have thought, well, wait a minute, why is this sandboxing and after? Like, why isn't it prevention? Well, because I can't take a file and detonate it in a VM and execute it and keep an HTTP connection as an example live, right? Not for the time it takes for me to do the analysis. So that's going to allow the traffic to come in. That file will land on an asset. And then within, minutes to half an hour, I'll get an understanding of what that file is. And if it's bad, I certainly want to make everything that sees that file moving forward, but also go back in time and let me know something bad has happened in my environment, even though I failed to detect it the first time. Now, we're talking about VPN. So this is the remote support engineer. Now, if you don't have control over this asset, meaning that it's a manufacturer coming in to VPN to do some work on something, and you're going to allow that connection inbound, then you're going to need the network to provide a lot of these capabilities because you certainly don't trust that asset. And so you're going to have things like, next-gen firewalling and DDoS capabilities. Why is DDoS important for a VPN front end? Well, if they take down that VPN, especially nowadays, right? Now the internet has become the business network for everyone. They essentially can shut down that organization. So something like distributed denial of service, we're seeing more of that, and certainly want to front our VPN head ends to protect those from that type of an attack. You've got TLS decryption. So this is if it's an HTTPS connection, certainly want to do a decryption of that. If you don't, then you're not actually inspecting anything with that traffic. So there's no IPS happening, intrusion prevention. There's no malware inspection. It's blind. You're blind to that. And again, you're going to have to rely on the endpoint. You got multi-factor authentication. You got endpoint posture. You've got geo control. So maybe, and again, this is pretty easy for an adversary to overcome because they'll just connect to a geolocation like the United States that might be trusted. But it is another hurdle, right? To help prevent. So if you have a mine and it's only in Canada, then and your engineers that support that environment are only in Canada, then maybe you should only have geo connectivity from that region, and make exceptions if needed. Then you get into layer 7 or application control based firewalling. So knowing the application is SSH and not based on port, but actually application, and then allow it to access based on the needs of the organization. And on the network side, you got advanced malware, again, from the network side. So the difference between this one and this one is this could be web-based focused only, and this could be network-based. Now, it could be that you don't have it here and you have it here. That's fine. You get into behavioral-based policy. So if I have critical assets in my industrial organization or environment, I have the ability to baseline the traffic patterns of those assets. And if I have a deviation from that, I could activity, meaning I could block something, I can create an alert. And that's where the behavioral-based policy comes in, because now I can use that as well as the asset that's connecting, the browser that they're using as a criteria to determine whether or not I want to take action against something. And then you get into web application firewall. And then now we move into detection and response and things that we want to capture. Because remember, if these fail, this is what the data that's going to be required to prevent us from shutting down the mine. Right? If the risk is that high. And so device insight, understanding the device and it connecting, denied authentications, right? So anytime that an authentication is denied, that might give us an indication of that. Host profiling, you got impact analysis. So host profiling is understanding the asset and everything on it. Impact analysis is understanding the impact to my organization and what that means to me. Sandboxing file analysis again, vulnerability insight, you got flow analytics, and then event packet capture. So we want to capture those packets, again, more for an incident response perspective than it is. You can also use it for troubleshooting as well, but we're really looking at the security aspects of it. And then the ability to use workflows to truly understand what's happening. And then you have a service on this end. In this case, it'll be RDP, and it will have some stuff on it too, right? So it might have some endpoint protection and some of the similar things that we've seen here.
So
that's
Jason,
one flow.
So before we go on to the next flow here, this is amazing detail, right? I mean, but quite frankly, it makes my head explode, right? So where do you start? Or are you going to go through that too later?
Yeah, so there's certain minimum needs in an organization. So endpoint, you need endpoint and you need visibility protection. But the gateways are certainly an area that you should have next-gen firewall capability and your endpoint. Those are especially in an operational environment.
Right? So that's a great point, actually. So the endpoint protection, a lot of that would be packaged in kind of one product or a couple of products, right?
So watch the next slide. Right. So
yeah,
this,
okay, cool.
the point of this, Roland, is exactly what you just called out. There's a lot of pieces here. In fact, many of these pieces I wasn't even thinking about. Right. And that's what I get from most, especially in the operational world. Right. These are some of the things that I really have not even thought about. And so when you look at it, how do you package this up? So this is the Cisco plug here, right? This is how we do it. So everything that's in red, we don't do. So there's very little. So on the endpoint, this is one solution stack for the most part, one product that provides all of these capabilities. Same thing on the DNS and web proxy functionality, right? That's all in one product as well. So you got secure endpoint, you got Cisco Umbrella, you've got Cisco DDoS, a little bit more simple one-to-one mapping there. Then you've got multi-factor authentication, you've got secure firewall, and you've got Cisco WAF, and then some maybe network behavioral analytics. Now, you might not see some of the other specific operational technologies, Roland, because I know your head's probably going, there's one here I'd probably add. That's coming in the next one. But now that you look at it, if I was to come into a room and say, well, all you need is secure endpoint, you might say, great, I'm going to buy it. But if you don't know the details around what you're actually getting, you could be missing something tremendously valuable, or a preventative mechanism that is tremendously valuable. So if I say, you need secure endpoint, everybody on this call says, yeah, that's a no-brainer, right? You need a next-gen firewall. Yeah, we're buying those, right? Maybe network analytics, we're not going there. That's something maybe a little more advanced. Or if you say multi-factor authentication, they'll go, yeah, that's something that we've added to our VPN. But again, each one of those technologies provide a set of capabilities, right? Security, although we want to be simple, it's not simple, right? The technology stack is becoming simpler, but the capabilities to drive towards a secure framework or posture are certainly complex. So that's an example of the flow. So it starts off a little bit complex and then starts to look at it from a product lens perspective. And yes, you might say, well, still I'm seeing 1, 2, 3, 4, 5, 6, 7, 8 products here to solve that one flow. And you're right, there is 8. But imagine having this from different vendors, all doing their own things a little bit differently, plus and minus a couple capabilities here and there. It definitely becomes very, very complex. And you wonder, well, you come to the conclusion, no wonder the adversary has the advantage. It's very easy for them to compromise anything in this environment because there's opportunity like no other. And so that's the one flow. Now, if you look at another flow, and this is where things start to speed up, is TTP jump host to an OT workstation. So you've created this landing zone to make sure that the asset that's connecting doesn't have direct access to the environment. So it goes into a jump host. That jump host then has some controls, very much like the endpoint. And then you've got these network-based controls again in that segment. So we've seen this already. We don't need to redo that. And then we've got this OT workstation that might allow us to install certain things on it as well to prevent. So, but now you see, all I've done now is overlay and change the two ends, and my controls are still the same. So my investment is exactly the same, right? There's no difference here. Now, it does change, though, depending on the flow. And so when you look at an OT workstation to an HMI, as an example, now things change a little bit, right? We're getting a little bit deeper into the environment, and I use Purdue here. That's what the L2 stands for, right? We're getting into touching from L3 to L2 at this point. And so you can see there's some similarities, right? They still have some protection here. Maybe, again, maybe you might have something here on the A1. You have some network stuff, right? So this looks like, in fact, it is. You've got some flow analytics. So anything that's TCP, IP, or Ethernet, I'm capturing that. So that's good. But what changes here? Well, this OT workstation may be something that gets plugged in that segment, right? Maybe it's a dynamic asset to some degree. But the ports in that network infrastructure probably should posture and profile and understand the assets that are connecting to that environment. And so now I want to posture and profile it. I might want to do micro or macro type segmentation. So isolate these things to only communicate with the things that they absolutely need to network, not at layer 3. And when I say layer 3 now, I'm talking about networks, not Purdue, not at an IP address, but at the MAC level, right? The MAC layer level. And so now I get into microsegmentation, and then you've got authentication logging and then posture state analysis. So the after side. So those two elements, and this could be wired or wireless, doesn't really matter. And then operational environment. So you start thinking about operational technology inventory. So what devices are in my environment, right? What are they? I'm talking about, operational things that might exist in my environment, not typical IT-based machines. I want to be able to understand that. I want to understand any assets in the operational environment that have vulnerabilities tied to it. I also want to baseline and look for anomalies within the operational environment. So if I'm reading a coil and that's all I do is read a coil, and all of a sudden there's a write activity in the environment, I want to know that. I want to know what Rockwell version code base is installed on it. I want all the inventory data around it. Why? Because I can feed that into my other security technologies, and again, I understand what's happening. And then you want OT asset modifications or configuration, any changes to the environment I want to track and I want to know, right? And so those are the two elements that I would change here. Again, you could plus and minus a few things, but you notice that this was more of a detection perspective versus a response action or a preventive action, right? I'm not blocking anything here. I'm passively listening, right? I'm deeper in the operational environment. And so I'm probably not going to actively probe things. I'm going to passively identify things. I'm not going to actively block things, but I'm going to audit and alert. So a little bit different behavior in all of this. And then you've got operational technology intrusion detection systems, right? The ability to determine some intrusion in the operational environment that's specific to the operational environment and signatures that are meant for the operational environment. And so when you look at that, the only two differences in that flow, we've gotten rid of umbrella because we're not going to use maybe cloud-based. But now I've got Identity Services Engine, or NAC. We want to remove the product name. And I've got Cisco Cyber Vision. So a tool that understands the operational environment, the patch levels, IDS, anomalies, inventory, all of that stuff, very specific to that. And those are the two pieces that I would pull out, you're not going to do duo or multi-factor authentication, so that goes. You're not going to do DDoS, that goes. And that helps me also with sizing, right? Because I know it's not needs, but I do have some additional needs for the organization. And in fact, if you think about it, many of these technologies already exist in your IT network, right? So they have an OT spin on them. So for example, our secure endpoint has a full audit mode. So you can run in 100% audit mode and never block anything. Now, it's not going to prevent anything, but it's at least going to let us know. But it also won't interrupt any processes, operational processes as well. Then you've got OT profiling for your NAC-based systems. So how do you do that? Well, maybe Cyber Vision can share that information. We just said that there's a tool here that's identifying the assets in the network, and I can share that. Now I can do micro or macro type segmentation. Then you get OT protocols and apps, and then OT protocols in general, right? Understanding what those operational technology protocols are and be able to decipher them and make sense of them, and obviously help with asset inventory and such. Now, this is where things really start to add value, is the platform-based approach. And I know I'm coming up. I got about a few more minutes here, but we're wrapping up around the corner here. So I've got a Cisco switch, and this could be any switch, but let's assume a Cisco switch. And I've got these products that we've just talked about. I didn't include them all, but here's an idea of how this all comes together. Is that if I have something connect to the switch, I can authenticate and profile it. I can posture it and assess it and reduce risk. Think of zero trust. This is an element of zero trust in the operational environment. Then I can do additional enforcement. So based on information I get here, I could tell that data that's coming into the analytics engine, I could then share that information with Identity Services Engine to take action. Cyber Vision also provides asset inventory to ICE. So if I plug in a device that's an operational device ICE will know about it and can build a policy around it to let it connect to the network and only have access to the resources it needs access to. I can block upstream. So I can use this information to block upstream. So even though cyber vision is more of a detection and maybe response type tool, no real preventative capability, and things change, I could actually leverage a device upstream and have it take action against something. Cyber vision can also feed information into the network analytics engine. And then you've got secure endpoint that can provide additional insight into an asset that may be compromised, and the services engine or NAC could take action against it. Again, you're going to take this with a grain of salt because there's going to be areas of the network you do not want to block or do anything with. But places where you can, or assets that you can, this will help elevate your ability to mitigate risk. And then, so wrapping up here, you've got your operational environment. You need intelligent feeds, right? That intelligence comes from vendors. It comes from open source solutions, right? ISACs, all of them out. There's a ton of open source. And you might say, well, some of that's business related. Yeah, but it may impact that operational environment. And so there's some value in that. Hunting and incident response, so the ability to be able to understand what's happened on the endpoint and the network and tie it all together into a big picture. And then you want maybe some automation and some orchestration, again, with a grain of salt here. So these are things that you want to layer on top of anything that you do here. You want to make sure that these three elements are being considered throughout. And then ultimately, you're going to tie into the business network. So there's a tremendous amount of experience in this environment that may be able to trickle down and help empower the operational environment with some additional traditional tools made for the operational environment. So in closing, this is the last slide here. This is going to be key in your response capability. There's a ton of telemetry out there. You need it centralized. It comes from a lot of different telemetry sources, right? I talked about some of the Cisco products, but again, take the Cisco names out, put whatever product you want there. These are the types of data feeds that you're going to get. Now, imagine if you were Colonial Pipeline and they're saying something's happened in the environment, we're going to shut down the pipeline. Wouldn't it be good that I could ask it everything I know about that particular campaign and threat? Technologies, tell me what you know. And it comes back and it gives me a good visual of all the relationships with good, bad, and ugly in one interface to let me know what might be happening in my environment. And very quickly, I might be able to say, we don't need to shut down the operational environment. We're good. And actually, we've added additional controls at the gateways to make sure that anything that's in the business network, which we clearly see, can never propagate down and further into our operational environments. So anyways, that's a kind of a step back. I know there's a lot of pieces there, but from a security perspective, that's the detail that you want. If not, you're going to end up with still some gaps in the environment. You might think you're checking boxes, yet you're still being compromised. And this doesn't give you 100% insurance either, right? This doesn't mean you don't get compromised, but it certainly makes it very, very difficult for the adversary to be successful.
You know what I find really fascinating, Jason, is the way that you described all of the different tools on the that are typical on the IT side, right? And mapped them almost directly into the OT environment. And I've often said to people, like, 80% of what you need on the OT side is already there on the IT side, right? The other 20% happens to be really critical and really important, but you also showed where you can weave those additional tools in and those additional requirements. So really, really cool. I'm going to have to go back and watch that over again to kind of absorb it all, but that was really, really rich. So thank you very much, Jason. And thank you for joining us in this session. Now we're done with day one, and we're going to start with day two sessions, which are next. The next session up is Wi-Fi. Just click on the next video and we'll take you there.